Hello. Hello. Am I audible? Hello. Please respond if I am audible, then we can start now. I'm not able to hear you. You can respond in the chat box.
Recording in progress.
Hello. Hello. Okay. 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 Are you able to hear me? Hello. Please respond in the. Okay. Okay. So you are able to hear me. So good afternoon. So I am Keshav. I am currently a PhD student in IIT Kanpur. So I will be taking this online problem solving session for this NPTEL course ME111. So in this week, in this problem solving session, we will discuss about the topics that has been covered in week 3. Okay. So how will we will go? First, we will try to revise or brush up the things that has been covered in week 3. Then we will solve some objective problems that will be similar to the assignment that has been given to you. Okay. Then we will try to write a pseudo code for Gauss elimination method. And by using this pseudo code, we will write a computer program to solve simultaneous linear equation using Gauss elimination method. Okay. So this week, the instructors has covered linear algebra problem, solving of linear algebra problems using numerical methods. Okay. So let me share my screen. I hope you are able to see my screen now. Okay. So we will start now. So in week 3, linear algebra problems has been discussed. Okay, actually I am in travel, network is too low. Okay, so now I will assume that you are able to hear me and see my screen. Whenever possible, you please respond. Otherwise, no need. Okay. So in this week, the instructor had covered that linear algebra problem, how this can be solved using different types of numerical methods. Okay. So basically, two types of linear algebra problems will be discussed here. The first type of problem is AX equal to B type of problem. This type of problem arises when we wish to solve linear equations, simultaneous linear equations. Okay. And second type of problem that will be solved is AX equal to lambda x problem. That is known as eigenvalue problem. Okay. So before going to the numerical methods that are used to solve the linear algebra problems, first, some basic fundamentals has been revised here, like what is vector? So you can answer directly vector. Vector is what? Vector has both magnitude and direction, and it is represented with an arrow. This is a geometrical representation of a vector. You have heard about the force, velocity, acceleration. These are all are vectors. Then there is a term called vector addition. Suppose you have a vector A, okay, some vector B. So how to sum these two vectors? We need to draw the parallelogram and complete it. So parallel to this vector, we need to draw dotted line. Similarly, parallel to a vector, we will draw the dotted line where these lines will cut from the tail of both the vectors where they meet. We will extend it to the point of intersection. That will give me C vector. C will be equal to summation of A plus B. Okay. Then similarly, scalar multiplication. What do we mean by scalar multiplication? Suppose we have some vector A, sorry, some vector Y and some vector X. Okay. So we can find vector Y. Sorry. Let me remove this. Suppose we have some vector X. So we can multiply it with some scalar to get some other vector Y. This is called scalar multiplication. And by combining both two, this vector addition and scalar multiplication, these two combinedly known as linear operator. Okay. So this is what this representation of vector with an arrow with some magnitude. It's known as geometric representation of vector. Similarly, in algebra, vector can be represented as ordered tuples. Okay. See, if our dimensionality is more than 3, it is not very easy. It is not very easy to represent in geometrical format. Okay. That's why for dimensionality more than 3, it is beneficial to represent vector in algebra format. So suppose we have some n-dimensional space that is represented as Rn. So in this n-dimensional space, any vector x can be represented by n tuples. These n tuples are ordered, means their order we cannot change. Okay. So as we have discussed that vector addition and scalar multiplication combinedly known as linear operator. Okay. So this linear operator, this lead vector, this n-dimensional space is closed under linear operators. Means what? Means what? Suppose if I take two vectors in n-dimensional space, okay, if I find their summation or some scalar multiplication, this resulting vector that will come from the scalar multiplication or the vector addition, it will remain in that n-dimensional space only. Okay, that's why suppose if we take some two vectors in 2D, two-dimensional space, their summation and scalar some multiplication in the vector, that will also remain in the same two-dimensional space. That means that R2 is closed under linear operator. Okay. Now, similarly, scalar multiplication or dot product is there. Why this is called scalar multiplication or scale dot product? Because we get result a scalar by dot product of two vectors. Suppose I have vectors x and vector y. Vector x is represented by n ordered tuples x1, x2, x3, xn dot dot. Similarly, vector y is represented as y1, y2, y3 goes to yn. Okay, similarly. So if we wish to find the scalar or dot product of these two vectors, this is represented as x dot y. Okay, and this will be equal to the multiplication of corresponding ordered terms. Means this will be multiplied by this will be multiplied by this term, third will be multiplied with third, and nth term will be multiplied by nth. So x dot y will give me x1, y1 plus x2, y2 plus x3, y3 dot dot dot. Okay. Similarly, x and yn. Now, these all things are very trivial, and these you have already studied in your mathematics course or at your intermediate level, 10+2 level. Okay, that's why I'm not going deep or anything. I'm just revising the thing what has been covered in week 3. Okay, so if two vectors are orthogonal, their dot product will be 0. And these two vectors are called orthogonal vectors. If their magnitudes are unit, means they have unit magnitude, then this will be called as orthonormal vectors. Means orthonormal vectors are vectors that are perpendicular to each other and that has a magnitude of 1. Okay, means unit vectors. Now suppose we have two vectors x and y, and we wish to find the component of x parallel to y and perpendicular to y. Means what? We have some vector x in this direction, okay, and some vector y in this direction, okay, and we wish to find the component of x along y and along perpendicular to y. Okay, so we here assume that the vector that is the component of x that is parallel to y is represented as x bar. Okay, and similarly the component of x that is perpendicular to y is represented by x perpendicular. Okay, now if I write since x prime is is parallel to y, it can be represented as x parallel will be equal to a multiplied by y. Okay, so we will able to find a, we can find x parallel. Okay, a is some scalar. Similarly, what else we can write? If you see here, if you see here, this is my x perpendicular vector, this is my x parallel vector. If we take summation of this parallel and perpendicular, this will give me the original x vector. This means the x will be equal to x vector will be equal to x parallel plus x perpendicular. Okay, this we can write as, so x perpendicular will be equal to x minus x parallel. It means if we will able to find a scalar a, then this scalar is multiplied by y, that will give us x that is parallel to y. And if we subtract this x parallel with x original x vector, that will give me the x perpendicular, means the vector that is perpendicular to y, or the component of x that is perpendicular to y. Now what we can do? This we can write x perpendicular will be equal to x minus a y. Okay, now we take if dot product of y in both side. Okay, so these y and x perpendicular are perpendicular, so this will lead to 0, will be equal to y dot x minus a y dot y, that will give me the norm of y square, means the magnitude of y square. Okay, so maybe I'm going in wrong direction. So let me erase. Maybe it will be better if I do this in some new page. Okay, so let me add one more page. Okay, so what we have now? We have x parallel is equal to ay, x perpendicular is equal to x minus x parallel. Okay, we also know since they are perpendicular, x perpendicular dot y, this will give me value 0. Okay, now if I write x dot y, that will give me what? That can be also written as x parallel plus x perpendicular multiplied by y. That will give me what? Plus 0. X dot y will be equal to what? X prime dot y. Okay, Similarly, x dot y now this x prime, how can we write? We can write a y dot y. This will equal to x and x dot y. So this is scalar, so scalar will come outside, then y dot y will be equal to x dot y. Now from here we will get a will be equal to x dot y divided by, this will give me what? This will give me the norm or magnitude square of vector y. So we have found out value of a. This value of a will lead to x parallel, that will be equal to a. A will be replaced by x dot y divided by square. Oh, sorry. Scalar multiplied by y. Okay. Now, if since we have found out the x parallel, x perpendicular will be simply x minus x parallel, that will be equal to x dot y divided by norm of y or magnitude of y square y. Okay. Now after this, what is called linear operator or linear operation? Suppose we have some function f, okay? Some function f. If some function f is represented by y equal to f of x, okay? So if this f, I can replace f x1 plus f of x2, that leads to f of x1 plus f of x2 and f of a of x will be equal to a of f of x. If these two conditions satisfied, this f function is called linear operator or linear function. Okay. In short term, linear algebraic equation can be represented as I equal to 0 to n ai x xi x to the power I equal to 0. Okay, where n is greater than. A general polynomial can be represented by a naught plus a1 x1 plus a2 x2 square plus dot 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 an xn to the power n equal to 0. This is general nth order polynomial equation. Okay. This can be represented in short term I equal to 0 to n ai x to the power I will be equal to 0. When this will be a linear equation. It will be a linear equation if this x square x cube dot 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 x to the power n, these all terms will be 0. This will be 0. This will be 0. That will lead to the linear equation. This means a2, a3, an will be equal to 0. This means the equation that will be linear, that will be represented like that. A naught plus a1 x will be equal to 0. This is the format of linear equation. Okay. Yes. So now simultaneous linear equation. So suppose we have n number of equation, n number of linear equation, m number of linear equation with n unknown. So I can represent this equation as some equation a x1 plus a1 2 x2 plus a1 3 x3 dot dot dot, that will be equal to b1. Similarly, second equation is my a21 x1 plus a22 x2 plus dot dot dot, that will be equal to b2. Mth equation will be what? am1 x1 plus am2 x2 plus dot 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 amn x1 xn, that will be equal to bn. So this equation can be, in short term, can be represented as, this all equation can be represented as summation aij x j will be equal to bi. Okay. In short term, we can represent it like that. Now suppose we have two linear equation, 3x plus 2y equal to 5, and another equation 4x plus 5y equal to 9. This equation can be represented in multiple fashions. This can be represented as scalar products of vectors. How we scalar products of vector? We can represent it as vector 3 2 multi dot product x y. If you multiply these two, that will lead to equal to 5. That will lead to 3x. This will be multiplied by this, and this will be multiplied by this. That will be equal to 5. Mean that will lead to 3x plus 2y equal to 5. So simultaneous linear equations can be represented as scalar products of vectors. Similarly, this can be represented as linear combination of vectors. Suppose this x multiplied by a vector, x is what? Scalar. Y multiplied by vector 2 5, that will be equal to a vector 5 9. Okay. So this is linear combination of vectors. If you multiply and compare that, that will lead to the same equation. I multiply this, that will be 3x plus 2y comma 4x plus 5y will be equal to 5 comma 9. This is what? Equality of vectors in format of equality of vector row form. Similarly, this can be represented in terms of column format, equality of vectors. This equality of vectors in column format, in short, we can represent it in matrix notation. How matrix notation? This can be represented as a multiplied by x, where a is equal to the coefficient and x equal to the variables that are unknown, and b equal to the right hand term. So a simultaneous linear equations can be represented as ax equal to b. Okay. So what is matrix? Is someone asked? Simply you can say matrix is a collection of vectors or arrays. Okay. So if matrix come, how to add a matrix. Two matrices with same dimensions can be added. Their respective terms will be added. Okay. In scalar multiplication, the scalar will be multiplied with the each element of the matrix. Equality of matrix. When two matrices will be equal, when their dimensions are same and each respective element of the matrix are equal, then two matrices will be equal. Then transpose of a matrix. If you interchange the row with column and column with row, that will lead to the transpose of a matrix. Then when we talk about square matrix, then two special matrix come, that is symmetric and skew or anti-symmetric matrix. What are they? If my matrix A and its transpose A transpose are equal, that is known as symmetric matrix. Okay. And if A transpose is negative of A, that is skew symmetric matrix. They are a special type of square matrix. Okay. Then some special types of square matrix has been discussed, like diagonal matrix. What is diagonal matrix? The diagonal terms will not be zero. At least one diagonal term will not be zero. Other terms will be equal to zero. Okay. Identity matrix means the diagonal term will be 1, another term will be 0. Okay. Upper triangular matrix means if I draw a triangle from here, so from diagonal and upper term will be non-zero and the lower term will be 0. Okay. So the terms below diagonal will be 0. That is known as upper triangular matrix. Similarly, lower triangular matrix, the terms above the diagonal will be 0. This is known as lower triangular matrix. Okay. Then what is permutation matrix? Permutation matrix has exactly ones in each row and each column. Okay. So this identity matrix is a type of permutation matrix. Okay. Suppose if I represent 1 0 0. Okay. 0 0 1 0 1 0. So this is a type of what? This is a type of permutation matrix. Since in first row it has only 1 1. In second row only 1 1. Third row only 1 1. If you see the column, only 1 1 present in each column. Okay. Then you already know what is the determinant of a matrix. That is represented by det of A. Suppose we have a matrix. This matrix we have. So we can find out the minor of the matrix, that is represented by Mij. That will be equal to what? Remove the ith row and jth column. So that will represent the minor of term Aij. Okay. And if I multiply this with -1 to the power I plus 1, that will give me the cofactor of element Ij. Okay. So cofactor will be equal to -1 to the power I plus 1 multiplied by the minor of element Aijth element. Okay. So determinant is nothing but determinant is equal to the summation of Aij multiplied the cofactors, where j goes from 1 to n. Okay. For any row we can do. Then singular matrix whose determinant is 0, det of A equal to 0, that will be a single matrix. And if det of determinant of A is not equal to 0, that will be what? Non-singular matrix. So if the matrix is non-singular, we can determine its inverse. Okay. So I square matrix that is non-singular, we can find out its inverse. How we can find out inverse? Suppose any matrix A which is square matrix and it is non-singular, then a inverse matrix exists such that A dot A inverse that will give me identity matrix. Similarly, A inverse A, that will give me identity matrix. So how to find out A inverse? We simply find cofactors for each element, cofactors for each Aij. Then we make a matrix using that cofactors. Then we divide by determinant. That will give me A inverse. Okay. So A inverse, this is a very tedious problem to solve in computer. That's why we always try to find another way to find the matrix inversion rather than going for this formula. Okay. This Gauss elimination and other terms that we will going to discuss in this course, that is some kind of matrix inversion technique, so that we can avoid this problem. This is a very tedious problem to solve in a computer. This involves lot of mathematical and algebraic calculation to find the inverse of a matrix. Okay. Now we reach to the main topic. The main topic that to discuss this Gauss elimination method, we have covered all this matrix, revision of matrix, vectors and all. Okay. So Gauss elimination is a technique to solve simultaneous linear equations. Okay. Simultaneous linear equation. So there are three types of Gauss elimination method. First, the earliest one, or the actual Gauss elimination, that is known as naive Gauss elimination matrix. What are they? We will discuss soon. Then Gauss elimination method with partial pivoting. There are some issue in the naive Gauss elimination method that can be resolved using partial pivoting in Gauss elimination method. Then Gauss elimination method with partial pivoting. Okay. Now suppose we have n linear equations with n unknown x1, x2, x3 dot dot xn. The first equation is represented as a11 x1 plus a12 x2 plus a13 x3. Similarly, a1n xn equal to b1. Second equation is represented as a21 x1 plus a22 x2 plus a23 x3, a2n xn equal to b2. Similarly, nth equation is represented by an1 x1 plus an2 x2, an3 x3 plus dot dot ann xn equal to bn. So how we try to solve this equation? What we try to do? We try to partially decouple the equation. How partially decouple the equation? We can completely decouple the equation. Completely decouple the equation means some term a dash xi will be equal to bi dash. If we represent this in this type of terms, means each equation has only one unknown, then this is known as completely decoupling. But we will not do complete decoupling here, but we will go for partial decoupling. Okay. Partial decoupling means the nth equation will have only one unknown xn. Similarly, the second last equation, n minus 1th equation, will have two unknown xn and xn minus 1. Since this equation we will solve first, so from here we will know the value of xn. So in this equation only xn minus 1 will be the unknown. So by using this we will find out the value. Okay. So this type of decoupling is known as partial decoupling. Okay. So this involved two steps. This Gauss elimination involved two steps. First step is was forward elimination. Second step is what? Back substitution. How we do that? Suppose we have equation 3x plus 2y equal to 5, 4x plus 5y equal to 9. Okay. By seeing this equation, you can say that the x equal to 1 and y equal to 1. If you put directly, you will get the answer. Okay. This can be represented in matrix notation format. Ax equal to b, 3, 2, 4, 5, x equal to xy, and b will be equal to a column vector 59. Okay. While solving these kind of problem in pen paper base, it is good to represent in a augmented vector format. So in that we will have only one matrix. In that matrix, we will apply the elimination technique, forward elimination technique, and find the value. Okay. So this is kind of short term notation. So here we represent the coefficient matrix A and the right hand side vector B in the same one matrix format. Okay. So what we do in forward elimination technique, in forward elimination, we select a pivot element that will be equal to the diagonal element of the ith row. Suppose here in the first row, the diagonal element is what? A11. So this is my pivot. Okay. So we select a pivot. Okay. Then what we do, we try to make all values to 0 in the same, in that pivot element column. Okay. So how we can do? So here, suppose 3 is the pivot element. So how can we make 0? We can replace row 2 with row 2 plus the element that is presented below that in the row, that element minus that element divided by the pivot element multiplied by row. If you do that, row 2 equal to row 2 plus the element on the pivot column divided by the pivot element multiplied by pivot row, that will lead to the element that's it below in the below to the pivot will be equal to 0. If you do that, you will get this matrix. Okay. Now if you see here, there is only one element left, and right hand side also we have only one element. So by using back substitution method, first we solve this equation. 7 by 3 y will be equal to 7 by 3. That will lead to y equal to 1. Then this equation 3x plus 2y equal to 5. If you put y equal to 1, that will lead to x equal to 1. Okay. So this is known as back substitution, and this is known as forward elimination. Okay. So we have seen Gauss elimination method for what? For a 2 simultaneous equations problem. Okay. Linear simultaneous equation. If we generalize this Gauss elimination, what will we suppose these are n equations, an equation with an unknown. Okay. So what we try to do, we try to convert this equation in form of this, means this term 0, this term 0, this term 0, and below the diagonal all terms are 0. Below the diagonal all terms are, sorry, this one will not be 0, this term 0. So we try to convert this kind of equation into this kind of equations. Okay. This kind of equation. So here what we are doing, we are simply, for pivot suppose A11, what we are doing, we replacing equation 2 with equation 2 plus equation 1 multiplied by A21 minus A21 divided by A11. Similarly, equation 3 is replaced by equation 3 plus equation 1 multiplied by A31 divided by A11. Okay. Similarly, in general, ith equation can be replaced by ith equation plus equation 1 multiplied by minus of I1 divided by A11. And B is replaced by what? So this can be represented as BI equal to, BI is replaced by BI minus B1 multiplied by AI1 divided by A11. AIJ will be replaced by Aij minus A1j multiplied by this factor AI1 divided by A11. For what? For j equal to means for other columns. Huh? J equal to 2, 3, ... n. Okay. Similarly, for second column, we can write this 1 will be replaced by 2. So bi will be equal to bi minus, obviously this bi will be not same as the earlier bi. This will be the new bi. So this bi will be equal to bi minus b2 ai2 divided by a22. Similarly, aij can be represented by aij minus a2j ai2 divided by a22. Okay, for j equal to 3 4 dot dot dot. So what are a11 a22? These all are pivot elements. So this can be represented as a pseudocode for k equal to 1 to k equal to 1 to n. N is the number of equations. Okay. So by one, we are selecting the pivot element. Then for each row, we are replacing bi with bi minus bk, aik, akk. And in each row, what we do, in each row for each column, what we are doing, we are replacing aij with aij minus akj, aik divided by akk. This is the factor that we are known. Okay. Now after that, what we'll do, we do back substitution. So in back substitution, the last equation is having only one term, a dash n x n, that will equal to b n dash. So here, from here we can find b n dash divided by a n dash. That will give me the value of a n. Similarly, a n minus 1 can be represented by b n minus 1 minus this equation. We have two terms. The second last equation will have two terms. So two terms how? A n minus 1. Sorry. This equation will have a n minus 1 comma n minus 1 multiplied by x n minus 1 plus a n minus 1 and x n, that will be equal to b n minus 1 dash dash dash. So what will be this x n we already know. So we'll put the value and we take this to the other side, that will be negative, and we divide by a n minus 1 n minus 1. Okay. So in general, this can be represented as bk. Suppose I want to find xk, that will be equal to bk minus summation of j equal to k plus 1 from k plus 1 to n, kj multiplied by xj divided by x a k k. Okay. Are you able to understand? Please respond. One of you please respond in the chat box. So now what we'll do, we'll first try to solve some objective problems. Okay. Then we'll try to make the program for Gauss elimination method. Okay. So first problem is, what will be the determinant of an n cross n permutation matrix? Can you please answer what will be the determinant of a n cross n matrix, permutation matrix? Yes, yeah, here. So if I add one more page here. So suppose permutation matrix what has? It has only, permutation matrix only has one in each row and one in each column. So this identity matrix is also a kind of permutation matrix. Okay. So this is my suppose a permutation matrix. If I find its determinant, so determinant will be what? Suppose this is equal to A. So determinant of A will be equal to what? If I find the cofactor of this matrix, so 1 multiplied by this will be multiplied by this and this will be multiplied by this. So 1 minus 0, that will lead to 1. Okay. So 1 will be a determinant of A matrix. A matrix is identity matrix, which is a special kind of permutation matrix. Suppose another matrix B I have. Okay. So 0, 1, 0, 1, 0, 0, 0, 0, 1. Okay. This is also a permutation matrix. Since in row 1, it has only 1, 1. In row 2, only 1, 1. Row 3, only 1, 1. Similarly, in each column, only 1, 1 is present. So if I find determinant of B, that will lead to 0 plus minus 1 multiplied by, if I find cofactor of this term, I find, so this will be what? This will be multiplied by this and this will be multiplied by this. So 1 minus 0, that will lead to minus 1. So the determinant of permutation matrix will be what? Either 1 or minus 1. Okay. Now suppose we have n cross n permutation matrix. So how many zeros and how many ones it will have? Okay. So you can understood like that. Suppose we have a 3 cross 3 permutation matrix. Okay, 3 cross 3 a permutation matrix. So it will have what terms? It will have 9 terms. Okay. And in each row or each column, it will have only 1, 1. Okay. So how many 1? Number of ones in permutation matrix. So suppose 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. So how many ones? 1, 2, 3. So 3. So if it is n cross n, ones will be what? 3 in number. Okay. In number. Similarly, how many 0 will be there? N cross n permutation matrix. How many zeros it will have? It will have n multiplied by n. Oh, sorry. N multiplied by n minus n. Okay. So if I take n common, so it will have, here it has 1, 2, 3, 3, 3, 6. No? Suppose we go for 4 cross 4. So 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. So 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So it will have n multiplied by n minus 1 zeros. Okay. Now, what will be the transpose of a upper triangular matrix? Please respond. What will be the transpose of a upper triangular matrix? You know what is upper triangular matrix? Upper triangular matrix has terms 0 below the diagonal. If I take transpose of it, its rows will become column and column will become rows. So it will transform into a lower triangular matrix. Okay, so it will be a lower triangular matrix. Similarly, if I want to represent a upper triangular matrix of n cross n with element a, I, j, how this can be represented? Can anyone please tell the answer in the chat box? Upper triangular matrix of n cross n dimension, its ith row and jth elements can be represented as aij. Then what option will be correct? Please respond. So suppose this is my upper triangular 1, 2, 3, 4, and 0, 0, 0. Suppose this is my upper triangular matrix. Okay. So this is my ith row, first row, second row, third row, fourth row. Na? So this is my first, second, third, fourth. This is my first, second, third, fourth. Okay. So all terms, this is what my, this is my a, I means the diagonal term. Okay. So if my I is greater than, if my I is greater than, is my row is greater than the column, this the term is 0. Na? So if my rows are greater than the column value, then the term is 0. So this will be my answer. Similarly, for lower triangular matrix, what will be the case? For lower triangular matrix, Aij will be equal to 0 if I is less than j. Okay, for lower triangular matrix. Now suppose we have a n cross n upper triangular matrix, two upper triangular matrix, then their multiplication will be what? Their multiplication will be also a upper triangular matrix. Okay, you can take any two upper triangular matrix and you can multiply and check, it will always come a upper triangular matrix. Okay, similarly, if two matrices are lower triangular matrix, if you multiply it, then this will give me a lower triangular matrix. Okay. Then suppose we have a upper triangular matrix, which is a non-similar, and if we find their inverse, its inverse, what it will be? Its inverse will be a upper triangular matrix only. Okay. Similarly, you take one upper triangular matrix that is a non-singular, means its determinant is not 0, and you find its inverse. It will always come on at a upper triangular matrix. Okay. Then suppose you have two vectors u and v. They will be orthogonal when their dot product is 0. Okay. So in Gauss elimination method, what we try to do? We try to convert AX equal to B type of problem, AX equal to B type of problem into CX equal to D type of problem, where C is what? C is what? Oh, sorry. C is what? If you see here, we have this kind of equation, a11x1 plus a12x2 equal to b1, and we make all the term below it 0. This will be a22, all term below it 0. Similarly here it will be a33x3, all term below it 0. So it will convert into a, C will be what? C will be a upper triangular matrix. Now, what is rank? Rank of a matrix means the number of independent rows or columns that are present in a matrix is known as rank of matrix. Means suppose if we have n number of equation, we represent it in a matrix format. If its rank is equal to n only, this means this n equation that we have, they are independent of each other. Okay. If they are not independent of each other, some equation can be represented by linear combination of other equation. Means we have n unknowns, but we do not have n number of independent equation. That in that case we will not able to find the value of these n unknowns. Okay. So if the equations are independent, means if its rank is equal to the order of the matrix, then only it will be satisfied. If the rank is less than n, then Gaussian elimination will fail. Okay. Now you solve and give me the answer for this value. We have equation 2x plus y equal to 3, x plus 2y equal to 3. We do Gauss elimination forward. In Gauss elimination, we do the forward elimination. Then what we will get? Either we will get x equal to y equal to 1, or we will get 2x plus y equal to 3 and 1.5 y equal to 1.5. Which option will be correct? Please answer. So what we'll do in Gauss elimination, we have equation 2x plus y equal to 3, and second equation what we have, x plus 2y equal to 3. Okay. So here this will be my pivot. So equation 2 will be replaced by what? Equation 2 old minus or plus the corresponding column element minus 1 divided by pivot element multiplied by equation 1. If we replace this, equation 2 will be, equation 1 will remain as same, equation 1 will remain same, and equation 2 will become 0 plus 2 multiplied by minus 1 by, right here, sorry, 0 plus equation 2, 2 minus 1 by 2 multiplied by the term in equation 1, 1. Why? That will be equal to what? Equation 2, 3 minus 1 by 2, 1 by 2 multiplied by term in equation 1, 3. B in equation 1, 3. Then that will lead to, this will lead to 1.5 y will be equal to 1.5. So which option will be correct? This option will be correct. Okay. No problem. If you are not able to follow now, you can watch this video once its recording is uploaded. Okay. Now, these all things are very trivial that we have discussed. Now we'll see the main part of this online discussion hour. Okay. Which is what? To represent. Now we'll try to represent Gauss elimination technique in a computer program. Okay. So before going to the computer program, we need to see the pseudocode. Okay. So this is the kind of pseudocode. Na? For each pivot element, what we do, for each pivot element, we go in each rows, means in each equation, we replace bi is equal to bi minus bk, k is the pivot element row, multiplied by the factor aik divided by akk, the pivot element. And in that equation only, in each column, we replace aij with aij minus akj multiplied by aik divided by akk. Okay. So first, this is the forward elimination. So now we'll try to represent this forward elimination in a computer program. Okay. So what we have, suppose k is my pivot row. Okay. And this pivot row will start from 1. K will be start from 1 and it go to n minus 1. Why it will go to n minus 1? Since we do not want to make the nth equation term 0, it should remain non-zero. Na? So k will go to the pivot one. So for k equal to 1 to n minus 1, then for each equation, I is each equations. So for I equal to k plus 1 to nth, what we will do? We will replace bi to bi minus the factor. Factor is what? The kth column term in the row, which is a ith row kth column divided by a kk multiplied by bk. Okay. Then after that we will go in each equation, each column term means j will now go to what? J will start k plus 1. So j will start from k plus 1. Here suppose we have akk. Suppose this is my a11, a12, a13, a21, a22, a23, a31, a32, a33. So suppose this is my pivot. So what we'll do? We'll go to the next equation, and this term will be replaced by what? This means if akk is my pivot 1, k is equal to 1, then my pivot is a11. Then a22, the replacement will start from a to t. This will become already 0. This will become 0. So akk from 2 to n, aij will be replaced by aij minus a ith row kth column term divided by the pivot term multiplied by a kth row j term. Okay. So this is the forward elimination. Now we will try to represent in a computer program. Okay. So I will stop share from here. And I will share from my PC now. Okay. So now I will share my screen from computer. I hope you are able to see my screen now. Suppose we want to solve a equation. We want to solve equation x plus we want to solve equation x plus 10y plus 20z equal to 31. Okay. The second equation is 10x plus y plus 20z equal to 31. And the third equation is 20x plus 10y plus z equal to 31. Okay. These equation we wish to solve. This simultaneous linear equations we wish to solve using Gauss elimination method. Okay. Okay. So first I will what will do, I will import numpy library, import numpy as np. Okay. Then I will take input. What will be my coefficient matrix A? Coefficient matrix A will equal 1, 10, 20, 10, 1, 20. Then third row will be 20, 10, 1. And what will be my this B matrix? 31, 31, 31. So now I will represent what A will be equal to. A will be equal to 1, 10, 20 in the first row. This is my coefficient matrix. Then second row 10, 1, then 20. Then third row 20, 10, 1. And my B matrix is what? 31, 31. And third one is also 31. Okay. So this is my, if I do simply print A, print B, if I press shift enter, so it show me first the coefficient matrix A, then the matrix B. Okay. So this is my matrix A and B I have defined. Now what I need to do? I need to first apply the forward elimination. Forward elimination. Forward elimination. Okay. Forward elimination what? first we need to select the pivot element na, and pivot element will go from what? Pivot element will start from 1 from the first row, but it will not go up to the n. It will remain till n-1. Okay. So suppose I define, in general, this may not be equal to the 3 cross 3 matrix. It may be equal to some n cross n matrix. In that case, suppose you have defined A, okay, or you have taken input from the A, from the user, the matrix A and B. Okay. In that case, we simply need to find out the number of equations or number of the unknown that is involved. Okay, if you want, you can leave now. No issue. So this will be equal to the length of A. If I write length of A, simply, if I do to check whether it is going correctly or not, print and shift enter. See, the length is what? N is equal to 3. Now I need to do the forward elimination. So my pivot will go from what? From first to it will go to the n-1. So this can be represented in Python k in range n-1. Okay. So it will start from the, indexing start from 0 in Python. So it will start from 0 and it will go till n-2. Okay. I hope you have already learned about the range function and you have used it in some of your program. Okay. For range equal to, now for each pivot row, suppose I have selected the first column, it A11 is my pivot. Okay. So from the second row, I will replace the value now from second row. So for second row means k for I in range, it will start from k plus 1 and it will go up to what? It will go up to what? I want to go up to the last row. Last row means n. Okay. So I want to include the last row. No? So it will start from 0 and it will go to the n and with interval of 1. Okay. Now, what will be the value for each row? What will be the value of B? The B of I that was earlier, BI will be replaced by BI minus BK multiplied by, what will be the term? A, sorry, A kth row divided by A pivot element K, comma K. Okay. Now I need to replace the coefficient terms for other columns. Okay. So this can be replaced as for J that will go in range, This will also start from what? This will also start from a plus 1, and it will go up to what? It will go up to n. Okay, with interval of 1. Now, in each element A, I will replace A as, it will be represented like this. This is the syntax of Python. So A I comma j, A I j will be equal to A I comma j. This will be equal to A I j minus A I j minus A k j. K j multiplied by the factor. Factor is what? Factor is this term. Na? The pivot element will be in division format, and element that are in the same row, element that are in the same column, but in the ith row, ith column element in the ith row. So I simply see Control C, Control V. Okay. Now I have did the forward elimination. Suppose I just want to check what is the value of A and B after forward elimination. Okay. So I simply do shift enter. Okay. So this is my value. Okay. So equation 1 remains same. Equation 2 element changes. This becomes 99. This becomes 180. This 190, and this is 53 point something. And here it B first remains same. Second rows change, third row change. Now what I need to do? I need to apply what? I need to now apply back substitution. Back substitution. Okay. So in back substitution, what was the xn was what? Xn was simply bn divided by a and n. This was my ends. Or the other terms was what? Other terms was, suppose a n minus 1 I wanted to represent. So that was equal to b of n minus 1 minus xn multiplied by a n minus 1 row and nth column. Okay, this whole bracket divided by a n minus 1 comma n minus 1. Okay, this kind of, if in general we represent, this term will come into a summation. This term will come into a summation. So first what I will do, now I need to find the x values, na, value of unknown. So I just defined, simply I defined a x vector, x equal to np dot zeros, np dot zeros, np dot zeros. This will have what size? Size length of a comma length of, oh sorry, length of A comma 1 na? Means it will have 3 rows, whatever the length of A comma 1 column. Okay. This is my x. So simply in back substitution, I can write x of n x of n will be equal to directly what? X of n will be equal to what? Will be equal to b n divided by a comma n. Okay. Simply I shift enter. It is showing some error, na? Why it is showing some error? Okay, zeros comma one. Okay, so if I remove it directly, shift enter. Index 3 is out of bound in axis 0 with size 3. Okay. So why this error is coming? This error is coming because indexing start from 0 in Python. So if I simply print here, print and shift enter. Okay, so it has printed the value n as 3. But since indexing starts from 0, so my first row was 0th row, second row was first row, and third row was second row. So that's why I need to write here, it will go to n minus 1. It will be n minus 1, means the last row, means this is the last row. No? This is the last row, last column. Let me stop here from here. And I should start here from so in Python, this is I equal to 0. This is I equal to 1. So this will be I equal to n minus 1. This will not equal to n. This will be equal to n minus 1. Similarly, this will be equal to j equal to 0. J equal to 1. Dot 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 j equal to n minus 1. That's what that error was showing. Na? So whatever we have did, we need to now recheck and rectify accordingly. Okay. So I am stopping here from here. Now I will start here from this. Okay. Okay. Now if I do, so K start from 0 and goes up to, so here I need to write 1 less n minus 2. Here K starts from 1 and it goes from, so it inherently do not involve. Suppose I write range, and if I write, suppose here simply range and okay, print 15, but that is showing some print spelling. So it is range and okay. So it starts from 0. It's in at 2. It will include 0, 1, 2. So now if shift enter, it is showing some error. So simply we go. So k start from 1. So means k will start from 0. It will go to the n minus 1. So to go to the n minus 1, I need to write n minus 2 here. Similarly, I will start from 1. It will go to it is right, it is right, put enter. So simply suppose, right, it is now printing. Suppose I want to print xn, just enter. Okay. It is showing some error of sorry n minus 1. Just enter. Now for other n minus 1 at n minus 2 at n minus 3 at term I need to find. So simply I write for this is what back substitution for k equal to k in range it starts from what? It starts from n minus 1. It goes t to 1 with minus 1 steps. Okay. No, it will go to 0. Okay. So x of k, this will be equal to x of k will be equal to what? Some summation. So that sum I need to find. So suppose sum was initially 0. This sum, this sum I'm trying to find. So this sum is equal to 0 for j equal to j in range. So suppose I am finding the value for n minus 1th. So n minus 1th will include only the nth row term. And n minus 2th, suppose I want to find, so that will include n minus 1th and nth term. So my j will start from k plus 1. J will start from k plus 1. It will go up to and in one interval. With in each sum will become what? Sum will be equal to sum plus this a, here suppose a n minus 1 multiplied by n means what? A k comma j, a k comma j multiplied by x of k. Okay, this will be my sum. Now suppose I have find out the sum. So xk will be what? My xk will become, xk will be equal to, in bracket, bk minus the sum value that we got divided by what? Divided by a k k. Okay, I hope this will be my sum value. Now after doing this all, I want to print x. Okay, now if do shift enter. Okay, it is showing some error, some error. It has run successfully, but it hasn't run correctly. So I need to see where is the error. I hope I found out the value correctly. Yeah. So the error here is range. Okay, the error is range. If I write range start comma end comma the step. Okay, so in this case range start from this value. Okay, start from this value, but it do not include this 0. So I want to include this 0. So I will write what? N minus 1. So I want to go till n minus 1, and here I will start from n minus 2. Since I want to start from just suppose n minus 1 at all, I already know na. So I do not want to include n minus 1. So if I do shift enter, still it is showing 1, 2, 3. Let me see, I have already written this code. So yeah, these sum, this is what xj. Oh, oh, sorry. This will be xj now. This will be xj. This will be what? Xj. Since here, see, xj, xj. Now if I do shift enter, bk minus sum divided by akk. Sum will be equal to sum plus akj multiplies the xj. This is all right. K plus 1 to nth, it will go. This will start n minus 2, it will go up to this. This is all right, I think. Why it is showing some error? Oh, I need to define first sum equal to 0. It was earlier taking some garbage value. So sum equal to 0, I initially defined. Okay, now it will run correctly. See, now we have got 1, 1, 1. Okay, so this is the forward elimination, then back substitution. Okay, earlier what was the error? Since I was using sum, but sum was not assigned to 0. So it was already some, that was some, suppose after first k equal to, suppose k equal to n minus n, it got some value, then it was added into that value. Okay, now suppose I want to solve some another equation problem. Suppose I want to solve a problem. Now I want to solve a problem. I want to solve a problem 3x plus 2y plus 3z, okay, plus some w equal to 9. This is my first equation. My second equation is 4x plus 5y plus 1z plus 3w 3w, that equal to 13. And third equation is x plus 2y plus 7z plus 2w equal to 12. My fourth equation is 4x plus 2y plus z plus 6w equal to 13. Okay, this is my equation. So I wish to solve this equation. Okay, this equation I wish to solve. So how can solve? I can solve this equation. Simply I need to replace coefficient matrix and B matrix. So B's matrix is what here? B matrix here is 9. So here B matrix is what? 9. Then it is 13. Then it is what? It is 12. Then it is again 13. Okay. What is my A matrix? A matrix is 3.0, comma 2.0, comma 3.0, comma 1. Okay. What is my second row? Here, what is my second row? My second row will be 4, 0, comma then it will be 5, then 1, then 3. Okay, what will be the third row? Third row of coefficient matrix, 1, comma 2, then it will have 7, then it will have what? 1, then it will have 6. Okay, one, two, 7, 2, sorry, 7, 2. Now fourth row value, what will be? It will be fourth row value. It will be 4, then it will be 2, then what? 1, then what? After that, 6. Okay, so 3, 2, 3, 1, 3, 2, 3, 1, 3, 2, 3, 1. Okay, then 4, 5, 1, 3, 4, 5, 1, 3. Then 1, 2, 7, 2, 1, 2, 7, 2. Okay, then 4, 2, 1, 6, 4, 2, 1, 6. Okay, 9, 13, 12, 13. So if I simply do shift enter, see, I got 1, 1, 1. If you solve this equation, you will get one value only. Okay, now suppose I will stop here from here. Okay, so this was the simple problem. No? Now if we go for partial pivoting and scaling, the back substitution will be this remain same. Back substitution will remain same. Only what we need to check, suppose we have some AKK as pivot, some AKK as pivot. So in partial pivoting, what we do, we make sure the element that are below it, suppose kth column, I will say kth column in partial pivoting. Suppose I go for k plus 1, k plus 2, k dot 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 and k. Okay, so suppose this is my pivot. So what we do in partial pivoting, we go and check this element, this element, this element, this element. If any of these element is greater than this, means if suppose for j equal to, I am going from k plus 1 to n, if I find any value, absolute value of or mod of a jk, if I find this is greater than my mod of a kk, so simply what I do, I replace, I switch, I simply interchange, interchange jth row with the kth row. Okay, I will simply interchange. If I find any value that is greater than this pivot value, I simply interchange this row and this row will come here. Okay, so there is one issue also. One more improvement can be the scaling term. means scaling term. What we are trying to see here, if this term is smaller than this term, okay, or this term is large than this term, okay, this term is larger than this term, so we want to interchange it. But how large? To find the relativity of the large term, we simply what we do, here we have one row, two rows, k plus 2th row, k plus 8th row, k plus 4th row. Like that we have, suppose a k plus 1, k plus 2, k dot a n k, suppose. ठीक है, this we have. Simply here we have some element a k plus 1, a k comma k plus 2 dot a k n. Okay. Similarly, here we have some element, we have some element, we have some element. So what we do, suppose this is my pivot element. Okay. What we try to do, first we find in this row what is the maximum value. This row maximum we find, row maximum we find. Then we divide this pivot element with this row element, row max value. Okay. So that will give me what? That will give me a k in the ith row divided by a k in the ith row max. Okay. Sorry, a k divided by a k in the ith row, means this row, whatever will the max value. Okay. We'll divide that. Similarly, in this row also, this value divided by the maximum value of the row. This value divided by the maximum value of this row. This value divided by the maximum value of this row. Then we compare this ratio, whatever we got. Then rather than comparing the term itself, we compare its ratio. Ratio of what? Ratio of the kth column element divided by the maximum value in the same row. Okay. So how we can do that? Now we will see. Okay. So here I have already did. So 6 enter. The same equation we want to solve. What was the equation? X plus 10y plus 20z equal to 31. No? 31. And then what? Then 10x plus y plus 20z equal to 31. Then what? 20x plus 20x plus what? 20x plus 10y plus z equal to 31. This equation we want to solve. Okay. Fine. This equation if I want to solve, so simply first I define that a, b, and x. Okay. This is same for this backward substitution will be the same. Now in doing, when we are going for forward elimination, what we need to do before doing this bi equal to bi minus bk aik akk, before doing this we want to swap the row value. If the row value, if the same column value divided the maximum value in that row is greater than what? Maybe I should write here. What we try to do here, suppose Suppose K is the K is pivot element. Okay, AKK is pivot element. Suppose AKK is pivot element, then what we will do? First, we divide AKK with the maximum value in the kth row. Okay, first we divide the maximum value. We divide AKK with the maximum value in the kth row. Okay, so suppose this is my the pivot K is going for the key pivot. K is the element that is representing the pivot. So what I do, I first find some maximum value that will be equal to the absolute of AKK, means the pivot value, divided by the maximum value in the kth row, including all the columns. This column is representing all the columns. Okay, so kth row, all the columns. So it represents that the kth row. Now I take the absolute value, so it will give me the absolute value of the kth row. Okay, now if I apply this npi dot match, so it will give the maximum value in the kth row. Okay, so this maximum value in the kth row, that absolute value will divide my AKK. Okay, mod of AKK. So I should directly say that. Okay, now kth row, if I find out, now after that what I will do, I will find the I will find the find in kth column whether any element divided by maximum in its row has greater value or not. So simply what I do now, I go for I in range that start from K, is goes to N with one step. What I do, I simply check. Suppose I equal to K, I equal to K plus 1. So I simply what I do, I check absolute of that column value divided by the maximum value in that row. If that value is greater than my maximum value, if yes, then my row number will be what? That the ith row. Simply that I will do for all the rows. Once I have done that, I will get the row number that has the maximum AIK divided by in the same row maximum value. Okay, then simply what I will do, I will replace the kth row with the row num that we have found. Okay, for same A and B both. Okay, then what? Then the usual procedure what we have did in naive Gauss elimination, that we will do. Only that we first check whether these two conditions are satisfied or not. If not, we will swap kth row and row num. Okay, now if I press shift enter, Now if I press shift enter, you see, we are getting the same x value 1. But here, if you see, we are not getting the same coefficient matrix and the same B matrix after Gauss elimination. Earlier, what we were getting, suppose I run this. This is the naive Gauss elimination. It's simply I press shift enter. Here, what we are getting, this is our coefficient matrix after naive Gauss elimination, and this is our B matrix after Gauss naive Gauss elimination. So last element is C minus 53.454. Similarly here, if I see in the other one, means the Gauss elimination with partial purity and scaling, we are getting some different coefficient matrix after Gauss elimination with partial pivoting and scaling, but we are getting the same value. Okay. So these two are the things that we do when we are going for partial pivoting and scaling. If I want to do only partial pivoting, what I need to do? I simply remove this term. Now, this term will be removed. So only AK absolute of AKK will be compared with this term. Now this is what? Now this is what? This is only partial pivoting. If I want scaling, if I want to do scaling also, I need to divide it. I need to divide with the maximum value in the same row. Okay. It is showing some error, so maybe 1 or 2 brackets are missing. Okay. Okay. So once we did, when first time it got run, row 1 and row 2, first it was what was one? First row 0 and row 2, means the first row and third row interchanged. Then what? Then row 1 and row 2 interchanged. Okay, in the second round. So I think this is all for today. I hope you guys have understood how to do Gauss elimination program. Okay, sure. Please go through, and if you have any doubt, you can ask. Okay, so I will stop here. So what we have did first, we have revised whatever the instructor had taught in this week. Then we have seen what is the Gauss elimination technique, the basic one, or the naive Gauss elimination. Then we have seen Gauss elimination with partial pivoting and with scaling. We have made the computer program for naive Gauss elimination and for the Gauss elimination with partial pivoting and scaling. Okay, so you please do try to write the same, and if you have any problem, you can ask. You try to make the computer program. If you see any errors, what you do, you go to the Google and search how to, suppose you want to find the maximum in each row. So you simply go to Google and search how to find the maximum in each row of a matrix in NumPy. Then it will give some results. Then go through that. and try to implement in your code. Okay, like that, slowly you will find some errors, you will rectify that, and this is how you will be able to make a computer program. Okay, this program also I have made in MATLAB also. So suppose if I simply run it, see, it is asking what is the number of equation and number of unknowns. So, oh, sorry, I need to share the screen again. So, share screen. See, so suppose I just run again. So enter the number of equations and number of unknowns. Suppose three equations, three unknown. So it asking me to enter the coefficient matrix values. So what was the values? If I see here, what was the values here? So value was what? 1, 10, 20, 10, 1, 20, so 1, 10, 20. Na? So I simply need to take. Okay, so I need to run it again. Okay, so three, what will the value? First value is 1, then 10, then 20. Then what was the value? 10, 1, 20. So 10, 1, 20. Then what was the value? What was the value? 20, 10, 1. 20, 10, 1. So this is my A matrix. Now I need to enter what? I need to enter the B matrix value. So 31, 31, 31. Okay. Okay, so maybe I need to do some changes here. So suppose I want to use the naive Gauss elimination. So simply what I will do, I will comment it. And this also I will comment. One, 10, 20, 10, 1, 20, 10, 1, 20, then what? 10, 1, 20, then 20, 10, 1. 20, 10, 1, then 31, 31, 31. See, this was my matrix after the Gauss elimination. And this is my B matrix after Gauss elimination, and value we are getting X as 111. Okay. So the 53 something we are getting here. And in Python also 53 or something we are getting. See here, the same we are getting. Now, if I want to go for what? This with scaling and all, what I need to do? I simply select from here to here and uncomment it. I have uncommented it. Now I will run this section. Now I will run this section. See 27 something coefficient matrix, the last element, and B matrix 27.9. Here also we are getting 27.9. See 27.9. Now if I run the back substitution, see we are getting the value 111. Okay. So this is how you can take input from the user also, na? You input from the user a matrix. Okay. So I will stop here from now. So I will stop here. If you have any doubt, please ask. Okay, thank you. So I am stopping this meeting.